Part I. Introduction to the Logic of Science. A survey of some fundamental problems. A scientist, whether theorist or experimenter, puts forward statements, or systems of statements, and tests them step by step. In the field of the empirical sciences, more particularly, he constructs hypotheses, or systems of theories, and tests them against experience by observation and experiment. I suggest that it is the task of the logic of scientific discovery, or the logic of knowledge, to give a logical analysis of this procedure, that is, to analyze the method of the empirical sciences. But what are these methods of the empirical sciences? And what do we call empirical science? The problem of induction. According to a widely accepted view to be opposed in this book, the empirical sciences can be characterized by the fact that they use inductive methods, as they are called. According to this view, the logic of scientific discovery would be identical with inductive logic, i.e. with the logical analysis of these inductive methods. It is usual to call an inference inductive if it passes from singular statements, sometimes also called particular statements, such as accounts of the results of observations or experiments, to universal statements, such as hypotheses or theories. Now it is far from obvious, from a logical point of view, that we are justified in inferring universal statements from singular ones, no matter how numerous, for any conclusion drawn in this way may always turn out to be false, no matter how many instances of white swans we may have observed. This does not justify the conclusion that all swans are white. The question whether inductive inferences are justified, or under what conditions, is known as the problem of induction. The problem of induction may also be formulated as the question of the validity or the truth of universal statements which are based on experience, such as the hypotheses and theoretical systems of the empirical sciences. For many people believe that the truth of these universal statements is known by experience, yet it is clear that an account of an experience of an observation or the result of an experiment can in the first place be only a singular statement and not a universal one. Accordingly, people who say of a universal statement that we know its truth from experience usually mean that the truth of this universal statement can somehow be reduced to the truth of singular ones, and that these singular ones are known by experience to be true, which amounts to saying that the universal statement is based on inductive inference. Thus to ask whether there are natural laws known to be true appears to be only another way of asking whether inductive inferences are logically justified. Yet if we want to end a way of justifying inductive inferences, we must first of all try to establish a principle of induction. A principle of induction would be a statement with the help of which we could put inductive inferences into a logically acceptable form. In the eyes of the upholders of inductive logic, a principle of induction is of supreme importance for scientific method. This principle, says Reichenbach, determines the truth of scientific theories. To eliminate it from science would mean nothing less than to deprive science of the power to decide the truth or falsity of its theories. Without it, clearly, science would no longer have the right to distinguish its theories from the fanciful and arbitrary creations of the poet's mind. Now this principle of induction cannot be a purely logical truth like a tautology or an analytic statement. Indeed, if there were such a thing as a purely logical principle of induction, there would be no problem of induction, for in this case, all inductive inferences would have to be regarded as purely logical or tautological transformations, just like inferences in deductive logic. Thus the principle of induction must be a synthetic statement, that is, a statement whose negation is not self-contradictory but logically possible. So the question arises why such a principle should be accepted at all, and how we can justify its acceptance on rational grounds. Some who believe in inductive logic are anxious to point out, with Reichenbach, that the principle of induction is unreservedly accepted by the whole of science and that no man can seriously doubt this principle in everyday life either. Yet even supposing this were the case, for after all, the whole of science might err, I should still contend that a principle of induction is superfluous, and that it must lead to logical inconsistencies. That inconsistencies may easily arise in connection with the principle of induction should have been clear from the work of Hume, also, that they can be avoided, if at all, only with difficulty. For the principle of induction must be a universal statement in its turn. Thus if we try to regard its truth as known from experience, then the very same problems which occasioned its introduction will arise all over again. To justify it, we should have to employ inductive inferences, and to justify these we should have to assume an inductive principle of a higher order, and so on. Thus the attempt to base the principle of induction on experience breaks down, since it must lead to an innate regress. Kant tried to force his way out of this difficulty by taking the principle of induction, which he formulated as the principle of universal causation, to be a priori valid. But I do not think that his ingenious attempt to provide an a priori justification for synthetic statements was successful. My own view is that the various difficulties of inductive logic here sketched are insurmountable. So also, I fear, are those inherent in the doctrine, so widely current today, that inductive inference, although not strictly valid, can attain some degree of reliability or of probability. According to this doctrine, inductive inferences are probable inferences. We have described, says Reichenbach, the principle of induction as the means whereby science decides upon truth. To be more exact, we should say that it serves to decide upon probability. For it is not given to science to reach either truth or falsity, but scientific statements can only attain continuous degrees of probability whose unattainable upper and lower limits are truth and falsity. At this stage I can disregard the fact that the believers in inductive logic entertain an idea of probability that I shall later reject as highly unsuitable for their own purposes, see section 0, below. I can do so because the difficulties mentioned are not even touched by an appeal to probability. For if a certain degree of probability is to be assigned to statements based on inductive inference, then this will have to be justified by invoking a new principle of induction, appropriately moded. And this new principle in its turn will have to be justified, and so on. Nothing is gained, moreover, if the principle of induction, in its turn, is taken not as true but only as probable. In short, like every other form of inductive logic, the logic of probable inference, or probability logic, leads either to an innate regress, or to the doctrine of a priorism. The theory to be developed in the following pages stands directly opposed to all attempts to operate with the ideas of inductive logic. It might be described as the theory of the deductive method of testing, or as the view that a hypothesis can only be empirically tested and only after it has been advanced. Before I can elaborate this view, which might be called deductivism, in contrast to inductivism, I must make clear the distinction between the psychology of knowledge which deals with empirical facts, and the logic of knowledge which is concerned only with logical relations. For the belief in inductive logic is largely due to a confusion of psychological problems with epistemological ones. It may be worth noticing, by the way, that this confusion spells trouble not only for the logic of knowledge but for its psychology as well. Elimination of psychologism. I said above that the work of the scientist consists in putting forward and testing theories. The initial stage, the act of conceiving or inventing a theory, seems to me neither to call for logical analysis nor to be susceptible of it. The question how it happens that a new idea occurs to a man, whether it is a musical theme, a dramatic concept, or a scientific theory, may be of great interest to empirical psychology, but it is irrelevant to the logical analysis of scientific knowledge. This latter is concerned not with questions of fact, Kant's quid facti, but only with questions of justification or validity, Kant's quid juris. Its questions are of the following kind. Can a statement be justified? And if so, how? Is it testable? Is it logically dependent on certain other statements? Or does it perhaps contradict them? In order that a statement may be logically examined in this way, it must already have been presented to us. Someone must have formulated it, and submitted it to logical examination. Accordingly, I shall distinguish sharply between the process of conceiving a new idea, and the methods and results of examining it logically. As to the task of the logic of knowledge in contradistinction to the psychology of knowledge, I shall proceed on the assumption that it consists solely in investigating the methods employed in those systematic tests to which every new idea must be subjected if it is to be seriously entertained. Some might object that it would be more to the purpose to regard it as the business of epistemology to produce what has been called a rational reconstruction of the steps that have led the scientist to a discovery to the ending of some new truth. But the question is, what, precisely, do we want to reconstruct? If it is the processes involved in the stimulation and release of an inspiration which are to be reconstructed, then I should refuse to take it as the task of the logic of knowledge. Such processes are the concern of empirical psychology but hardly of logic. It is another matter if we want to reconstruct rationally the subsequent tests whereby the inspiration may be discovered to be a discovery, or become known to be knowledge. In so far as the scientist critically judges, alters, or rejects his own inspiration, we may, if we like, regard the methodological analysis undertaken here as a kind of rational reconstruction of the corresponding thought processes. But this reconstruction would not describe these processes as they actually happen, it can give only a logical skeleton of the procedure of testing. Still, this is perhaps all that is meant by those who speak of a rational reconstruction of the ways in which we gain knowledge. It so happens that my arguments in this book are quite independent of this problem. However, my view of the matter, for what it is worth, is that there is no such thing as a logical method of having new ideas, or a logical reconstruction of this process. My view may be expressed by saying that every discovery contains an irrational element, or a creative intuition, in Bergson's sense. In a similar way, Einstein speaks of the search for those highly universal laws from which a picture of the world can be obtained by pure deduction. There is no logical path, he says, leading to these laws. They can only be reached by intuition, based upon something like an intellectual love, Einfühlung, of the objects of experience. 1. Deductive testing of theories. According to the view that will be put forward here, the method of critically testing theories, and selecting them according to the results of tests, always proceeds on the following lines. From a new idea, put up tentatively, and not yet justified in any way in anticipation, a hypothesis, a theoretical system, or what you will conclusions are drawn by means of logical deduction. These conclusions are then compared with one another and with other relevant statements, so as to end what logical relations, such as equivalence, derivability, compatibility, or incompatibility, exist between them. We may, if we like, distinguish 4 diarrhent lines along which the testing of a theory could be carried out. First, there is the logical comparison of the conclusions among themselves, by which the internal consistency of the system is tested. Secondly, there is the investigation of the logical form of the theory, with the object of determining whether it has the character of an empirical or scientific theory, or whether it is, for example, tautological. Thirdly, there is the comparison with other theories, with the aim of determining whether the theory would constitute a scientific advance should it survive our various tests. And finally, there is the testing of the theory by way of empirical applications of the conclusions which can be derived from it. The purpose of this last kind of test is to end out how far the new consequences of the theory, whatever may be new in what it asserts, stand up to the demands of practice, whether raised by purely scientific experiments, or by practical technological applications. Here too the procedure of testing turns out to be deductive. With the help of other statements, previously accepted, certain singular statements which we may call predictions are deduced from the theory, especially predictions that are easily testable or applicable. From among these statements, those are selected which are not derivable from the current theory, and more especially those which the current theory contradicts. Next we seek a decision as regards these, and other, derived statements by comparing them with the results of practical applications and experiments. If this decision is positive, that is, if the singular conclusions turn out to be acceptable, or varied, then the theory has, for the time being, passed its test, we have found no reason to discard it. But if the decision is negative, or in other words, if the conclusions have been falsified, then their falsification also falsifies the theory from which they were logically deduced. It should be noticed that a positive decision can only temporarily support the theory, for subsequent negative decisions may always overthrow it. So long as theory withstands detailed and severe tests and is not superseded by another theory in the course of scientific progress, we may say that it has proved its mettle or that it is corroborated by past experience. Nothing resembling inductive logic appears in the procedure here outlined. I never assume that we can argue from the truth of singular statements to the truth of theories. I never assume that by force of varied conclusions, theories can be established as true, or even as merely probable. In this book I intend to give a more detailed analysis of the methods of deductive testing. And I shall attempt to show that, within the framework of this analysis, all the problems can be dealt with that are usually called epistemological. Those problems, more especially, to which inductive logic gives rise, can be eliminated without creating new ones in their place. 2. The problem of demarcation. Of the many objections which are likely to be raised against the view here advanced, the most serious is perhaps the following. In rejecting the method of induction, it may be said, I deprive empirical science of what appears to be its most important characteristic, and this means that I remove the barriers which separate science from metaphysical speculation. My reply to this objection is that my main reason for rejecting inductive logic is precisely that it does not provide a suitable distinguishing mark of the empirical, non-metaphysical, character of a theoretical system, or in other words, that it does not provide a suitable criterion of demarcation. The problem of ending a criterion which would enable us to distinguish between the empirical sciences on the one hand, and mathematics and logic as well as metaphysical systems on the other, I call the problem of demarcation. This problem was known to Hume, who attempted to solve it. With Kant it became the central problem of the theory of knowledge. If, following Kant, we call the problem of induction Hume's problem, we might call the problem of demarcation Kant's problem. Of these two problems, the source of nearly all the other problems of the theory of knowledge, the problem of demarcation is, I think, the more fundamental. Indeed, the main reason why epistemologists with empiricist leanings tend to pin their faith to the method of induction seems to be their belief that this method alone can provide a suitable criterion of demarcation. This applies especially to those empiricists who follow the AG of positivism. The older positivists wished to admit, as scientific or legitimate, only those concepts, or notions or ideas, which were, as they put it, derived from experience, those concepts, that is, which they believed to be logically reducible to elements of sense experience, such as sensations, or sense data, impressions, perceptions, visual or auditory memories, and so forth. Modern positivists are apt to see more clearly that science is not a system of concepts but rather a system of statements. Accordingly, they wish to admit, as scientific or legitimate, only those statements which are reducible to elementary, or atomic, statements of experience, to judgments of perception or atomic propositions or protocol sentences or whatnot. It is clear that the implied criterion of demarcation is identical with the demand for an inductive logic. Since I reject inductive logic, I must also reject all these attempts to solve the problem of demarcation. With this rejection, the problem of demarcation gains in importance for the present inquiry. Finding an acceptable criterion of demarcation must be a crucial task for any epistemology which does not accept inductive logic. Positivists usually interpret the problem of demarcation in a naturalistic way. They interpret it as if it were a problem of natural science. Instead of taking it as their task to propose a suitable convention, they believe they have to discover a difference, existing in the nature of things, as it were, between empirical science on the one hand and metaphysics on the other. They are constantly trying to prove that metaphysics by its very nature is nothing but nonsensical twaddle, sophistry and illusion, as Hume says, which we should commit to the AMS. If by the words nonsensical or meaningless we wish to express no more, by definition, than not belonging to empirical science, then the characterization of metaphysics as meaningless nonsense would be trivial, for metaphysics has usually been deemed as non-empirical. But of course, the positivists believe they can say much more about metaphysics than that some of its statements are non-empirical. The words meaningless or nonsensical convey, and are meant to convey, a derogatory evaluation, and there is no doubt that what the positivists really want to achieve is not so much a successful demarcation as the null overthrow and the annihilation of metaphysics. However this may be, we envy that each time the positivists tried to say more clearly what meaningful meant, the attempt led to the same result, to a denition of meaningful sentence, in contradistinction to meaningless pseudo-sentence, which simply reiterated the criterion of demarcation of their inductive logic. This shows itself very clearly in the case of Wittgenstein, according to whom every meaningful proposition must be logically reducible to elementary, or atomic, propositions, which he characterizes as descriptions or pictures of reality, a characterization, by the way, which is to cover all meaningful propositions. We may see from this that Wittgenstein's criterion of meaningfulness coincides with the inductivists' criterion of demarcation, provided we replace their words scientific or legitimate by meaningful. And it is precisely over the problem of induction that this attempt to solve the problem of demarcation comes to grief. Positivists, in their anxiety to annihilate metaphysics, annihilate natural science along with it. For scientific laws, too, cannot be logically reduced to elementary statements of experience. If consistently applied, Wittgenstein's criterion of meaningfulness rejects as meaningless those natural laws the search for which, as Einstein says, is the supreme task of the physicist. They can never be accepted as genuine or legitimate statements. Wittgenstein's attempt to unmask the problem of induction as an empty pseudo-problem was formulated by Schlick in the following words: the problem of induction consists in asking for a logical justification of universal statements about reality. We recognize, with Hume, that there is no such logical justification, there can be none, simply because they are not genuine statements. This shows how the inductivist criterion of demarcation fails to draw a dividing line between scientific and metaphysical systems, and why it must accord them equal status. For the verdict of the positivist dogma of meaning is that both are systems of meaningless pseudo-statements. Thus, instead of eradicating metaphysics from the empirical sciences, positivism leads to the invasion of metaphysics into the scientific realm. In contrast to these anti-metaphysical stratagems, anti-metaphysical in intention, that is my business, as I see it, is not to bring about the overthrow of metaphysics. It is, rather, to formulate a suitable characterization of empirical science, or to deem the concepts empirical science and metaphysics in such a way that we shall be able to say of a given system of statements whether or not its closer study is the concern of empirical science. My criterion of demarcation will accordingly have to be regarded as a proposal for an agreement or convention. As to the suitability of any such convention, opinions may differ, and a reasonable discussion of these questions is only possible between parties having some purpose in common. The choice of that purpose must, of course, be ultimately a matter of decision, going beyond rational argument. Thus anyone who envisages a system of absolutely certain, irrevocably true statements as the end and purpose of science will certainly reject the proposals I shall make here. And so will those who see the essence of science in its dignity, which they think resides in its wholeness and its real truth and essentiality. 0 They will hardly be ready to grant this dignity to modern theoretical physics, in which I and others see the most complete realization to date of what I call empirical science. The aims of science which I have in mind are different. I do not try to justify them, however, by representing them as the true or the essential aims of science. This would only distort the issue, and it would mean a relapse into positivist dogmatism. There is only one way, as far as I can see, of arguing rationally in support of my proposals. This is to analyze their logical consequences, to point out their fertility, their power to elucidate the problems of the theory of knowledge. Thus I freely admit that in arriving at my proposals I have been guided, in the last analysis, by value judgments and predilections. But I hope that my proposals may be acceptable to those who value not only logical rigor but also freedom from dogmatism, who seek practical applicability, but are even more attracted by the adventure of science, and by discoveries which again and again confront us with new and unexpected questions, challenging us to try out new and hitherto undreamed of answers. The fact that value judgments inions my proposals does not mean that I am making the mistake of which I have accused the positivists, that of trying to kill metaphysics by calling it names. I do not even go so far as to assert that metaphysics has no value for empirical science. For it cannot be denied that along with metaphysical ideas which have obstructed the advance of science there have been others such as speculative atomism which have aided it. And looking at the matter from the psychological angle, I am inclined to think that scientific discovery is impossible without faith in ideas which are of a purely speculative kind, and sometimes even quite hazy, a faith which is completely unwarranted from the point of view of science, and which, to that extent, is metaphysical. Yet having issued all these warnings, I still take it to be the RST task of the logic of knowledge to put forward a concept of empirical science, in order to make linguistic usage, now somewhat uncertain, as denied as possible, and in order to draw a clear line of demarcation between science and metaphysical ideas even though these ideas may have furthered the advance of science throughout its history. 3. Experience as a method. The task of formulating an acceptable definition of the idea of an empirical science is not without its difficulties. Some of these arise from the fact that there must be many theoretical systems with a logical structure very similar to the one which at any particular time is the accepted system of empirical science. This situation is sometimes described by saying that there is a great number, presumably an innate number, of logically possible worlds. Yet the system called empirical science is intended to represent only one world, the real world or the world of our experience. In order to make this idea a little more precise, we may distinguish 3 requirements which our empirical theoretical system will have to satisfy. First, it must be synthetic, so that it may represent a non-contradictory, a possible world. Secondly, it must satisfy the criterion of demarcation, cf. sections and, i.e. it must not be metaphysical, but must represent a world of possible experience. Thirdly, it must be a system distinguished in some way from other such systems as the one which represents our world of experience. But how is the system that represents our world of experience to be distinguished? The answer is, by the fact that it has been submitted to tests, and has stood up to tests. This means that it is to be distinguished by applying to it that deductive method which it is my aim to analyze, and to describe. Experience, on this view, appears as a distinctive method whereby one theoretical system may be distinguished from others, so that empirical science seems to be characterized not only by its logical form but, in addition, by its distinctive method. This, of course, is also the view of the inductivists, who try to characterize empirical science by its use of the inductive method. The theory of knowledge, whose task is the analysis of the method or procedure peculiar to empirical science, may accordingly be described as a theory of the empirical method, a theory of what is usually called experience. 4. Falsifiability as a criterion of demarcation. The criterion of demarcation inherent in inductive logic, that is, the positivistic dogma of meaning, is equivalent to the requirement that all the statements of empirical science, or all meaningful statements, must be capable of being nally decided. With respect to their truth and falsity, we shall say that they must be conclusively decidable. This means that their form must be such that to verify them and to falsify them must both be logically possible. Thus Schlick says, a genuine statement must be capable of conclusive verification, and Weissmann says still more clearly, if there is no possible way to determine whether a statement is true, then that statement has no meaning whatsoever. For the meaning of a statement is the method of its verification. Now in my view there is no such thing as induction. Thus inference to theories, from singular statements which are verified by experience, whatever that may mean, is logically inadmissible. Theories are, therefore, never empirically variable. If we wish to avoid the positivists' mistake of eliminating, by our criterion of demarcation, the theoretical systems of natural science, then we must choose a criterion which allows us to admit to the domain of empirical science even statements which cannot be verified. But I shall certainly admit a system as empirical or scientific only if it is capable of being tested by experience. These considerations suggest that not the variability but the falsifiability of a system is to be taken as a criterion of demarcation. In other words, I shall not require of a scientific system that it shall be capable of being singled out, once and for all, in a positive sense, but I shall require that its logical form shall be such that it can be singled out, by means of empirical tests. In a negative sense, it must be possible for an empirical scientific system to be refuted by experience. Thus the statement, "It will rain or not rain here tomorrow," will not be regarded as empirical, simply because it cannot be refuted, whereas the statement, "It will rain here tomorrow," will be regarded as empirical. Various objections might be raised against the criterion of demarcation here proposed. In the RST place, it may well seem somewhat wrong-headed to suggest that science, which is supposed to give us positive information, should be characterized as satisfying a negative requirement such as refutability. However, I shall show, in sections 2, that this objection has little weight, since the amount of positive information about the world which is conveyed by a scientific statement is the greater, the more likely it is to clash, because of its logical character, with possible singular statements. Not for nothing do we call the laws of nature laws, the more they prohibit the more they say. Again, the attempt might be made to turn against me my own criticism of the inductivist criterion of demarcation, for it might seem that objections can be raised against falsiability as a criterion of demarcation similar to those which I myself raised against variability. This attack would not disturb me. My proposal is based upon an asymmetry between variability and falsiability, an asymmetry which results from the logical form of universal statements. For these are never derivable from singular statements, but can be contradicted by singular statements. Consequently, it is possible by means of purely deductive inferences, with the help of the modus tollens of classical logic, to argue from the truth of singular statements to the falsity of universal statements. Such an argument to the falsity of universal statements is the only strictly deductive kind of inference that proceeds, as it were, in the inductive direction, that is, from singular to universal statements. A third objection may seem more serious. It might be said that even if the asymmetry is admitted, it is still impossible, for various reasons, that any theoretical system should ever be conclusively falsied. For it is always possible to nd some way of evading falsification, for example, by introducing ad hoc an auxiliary hypothesis, or by changing ad hoc a definition. It is even possible without logical inconsistency to adopt the position of simply refusing to acknowledge any falsifying experience whatsoever. Admittedly, scientists do not usually proceed in this way, but logically such procedure is possible, and this fact, it might be claimed, makes the logical value of my proposed criterion of demarcation dubious, to say the least. I must admit the justice of this criticism, but I need not therefore withdraw my proposal to adopt falsiability as a criterion of demarcation. For I am going to propose, in sections 0f, that the empirical method shall be characterized as a method that excludes precisely those ways of evading falsification which, as my imaginary critic rightly insists, are logically possible. According to my proposal, what characterizes the empirical method is its manner of exposing to falsification, in every conceivable way, the system to be tested. Its aim is not to save the lives of untenable systems but, on the contrary, to select the one which is by comparison the test, by exposing them all to the ursest struggle for survival. The proposed criterion of demarcation also leads us to a solution of Hume's problem of induction of the problem of the validity of natural laws. The root of this problem is the apparent contradiction between what may be called the fundamental thesis of empiricism, the thesis that experience alone can decide upon the truth or falsity of scientific statements, and Hume's realization of the inadmissibility of inductive arguments. This contradiction arises only if it is assumed that all empirical scientific statements must be conclusively decidable, i.e. that their verification and their falsification must both in principle be possible. If we renounce this requirement and admit as empirical also statements which are decidable in one sense only unilaterally decidable and, more especially, falsiable and which may be tested by systematic attempts to falsify them, the contradiction disappears. The method of falsification presupposes no inductive inference, but only the tautological transformations of deductive logic whose validity is not in dispute. 5. The problem of the empirical basis. If falsiability is to be at all applicable as a criterion of demarcation, then singular statements must be available which can serve as premises in falsifying inferences. Our criterion therefore appears only to shift the problem to lead us back from the question of the empirical character of theories to the question of the empirical character of singular statements. Yet even so, something has been gained. For in the practice of scientific research, demarcation is sometimes of immediate urgency in connection with theoretical systems, whereas in connection with singular statements, doubt as to their empirical character rarely arises. It is true that errors of observation occur and that they give rise to false singular statements, but the scientist scarcely ever has occasion to describe a singular statement as non-empirical or metaphysical. Problems of the empirical basis, that is, problems concerning the empirical character of singular statements, and how they are tested, thus play a part within the logic of science that differs somewhat from that played by most of the other problems which will concern us. For most of these stand in close relation to the practice of research, whilst the problem of the empirical basis belongs almost exclusively to the theory of knowledge. I shall have to deal with them, however, since they have given rise to many obscurities. This is especially true of the relation between perceptual experiences and basic statements. What I call a basic statement or a basic proposition is a statement which can serve as a premise in an empirical falsification, in brief, a statement of a singular fact. Perceptual experiences have often been regarded as providing a kind of justification for basic statements. It was held that these statements are based upon these experiences, that their truth becomes manifest by inspection through these experiences, or that it is made evident by these experiences, etc. All these expressions exhibit the perfectly sound tendency to emphasize the close connection between basic statements and our perceptual experiences. Yet it was also rightly felt that statements can be logically justified only by statements. Thus the connection between the perceptions and the statements remained obscure, and was described by correspondingly obscure expressions which elucidated nothing, but slurred over the difficulties or, at best, adumbrated them through metaphors. Here too a solution can be found, I believe, if we clearly separate the psychological from the logical and methodological aspects of the problem. We must distinguish between, on the one hand, our subjective experiences or our feelings of conviction, which can never justify any statement, though they can be made the subject of psychological investigation, and, on the other hand, the objective logical relations subsisting among the various systems of scientific statements, and within each of them. The problems of the empirical basis will be discussed in some detail in sections 2-0. For the present I had better turn to the problem of scientific objectivity, since the terms objective and subjective which I have just used are in need of elucidation. 6. Scientific objectivity and subjective conviction. The words objective and subjective are philosophical terms heavily burdened with a heritage of contradictory usages and of inconclusive and interminable discussions. My use of the terms objective and subjective is not unlike Kant's. He uses the word objective to indicate that scientific knowledge should be justiciable, independently of anybody's whim. A justification is objective if in principle it can be tested and understood by anybody. If something is valid, he writes, for anybody in possession of his reason, then its grounds are objective and sufficient. Now I hold that scientific theories are never fully justiciable or variable, but that they are nevertheless testable. I shall therefore say that the objectivity of scientific statements lies in the fact that they can be intersubjectively tested. The word subjective is applied by Kant to our feelings of conviction, of varying degrees. To examine how these come about is the busyness of psychology. They may arise, for example, in accordance with the laws of association. Objective reasons too may serve as subjective causes of judging, in so far as we may react upon these reasons, and become convinced of their cogency. Kant was perhaps the first to realize that the objectivity of scientific statements is closely connected with the construction of theories with the use of hypotheses and universal statements. Only when certain events recur in accordance with rules or regularities, as is the case with repeatable experiments, can our observations be tested in principle by anyone. We do not take even our own observations quite seriously, or accept them as scientific observations, until we have repeated and tested them. Only by such repetitions can we convince ourselves that we are not dealing with a mere isolated coincidence, but with events which, on account of their regularity and reproducibility, are in principle intersubjectively testable. Every experimental physicist knows those surprising and inexplicable apparent eeks which in his laboratory can perhaps even be reproduced for some time, but which nally disappear without trace. Of course, no physicist would say in such a case that he had made a scientific discovery, though he might try to rearrange his experiments so as to make the eek reproducible. Indeed, the scientifically significant physical eek may be deemed as that which can be regularly reproduced by anyone who carries out the appropriate experiment in the way prescribed. No serious physicist would owe for publication, as a scientific discovery, any such occult eek, as I propose to call it, one for whose reproduction he could give no instructions. The discovery would be only too soon rejected as chimerical, simply because attempts to test it would lead to negative results. It follows that any controversy over the question whether events which are in principle unrepeatable and unique ever do occur cannot be decided by science. It would be a metaphysical controversy. We may now return to a point made in the previous section, to my thesis that a subjective experience, or a feeling of conviction, can never justify a scientific statement, and that within science it can play no part except that of an object of an empirical, a psychological, inquiry. No matter how intense a feeling of conviction it may be, it can never justify a statement. Thus I may be utterly convinced of the truth of a statement, certain of the evidence of my perceptions, overwhelmed by the intensity of my experience. Every doubt may seem to me absurd. But does this afford the slightest reason for science to accept my statement? Can any statement be justified by the fact that KRP is utterly convinced of its truth? The answer is, no, and any other answer would be incompatible with the idea of scientific objectivity. Even the fact, for me to so RMLY established, that I am experiencing this feeling of conviction, cannot appear within the eld of objective science except in the form of a psychological hypothesis which, of course, calls for intersubjective testing. From the conjecture that I have this feeling of conviction, the psychologist may deduce, with the help of psychological and other theories, certain predictions about my behavior, and these may be confirmed or refuted in the course of experimental tests. But from the epistemological point of view, it is quite irrelevant whether my feeling of conviction was strong or weak, whether it came from a strong or even irresistible impression of indubitable certainty, or self-evidence, or merely from a doubtful surmise. None of this has any bearing on the question of how scientific statements can be justified. Considerations like these do not, of course, provide an answer to the problem of the empirical basis. But at least they help us to see its main difficulty. In demanding objectivity for basic statements as well as for other scientific statements, we deprive ourselves of any logical means by which we might have hoped to reduce the truth of scientific statements to our experiences. Moreover, we debar ourselves from granting any favored status to statements which describe experiences, such as those statements which describe our perceptions, and which are sometimes called protocol sentences. They can occur in science only as psychological statements, and this means, as hypotheses of a kind whose standards of intersubjective testing, considering the present state of psychology, are certainly not very high. Whatever may be our eventual answer to the question of the empirical basis, one thing must be clear: if we adhere to our demand that scientific statements must be objective, then those statements which belong to the empirical basis of science must also be objective, i.e. intersubjectively testable. Yet intersubjective testability always implies that, from the statements which are to be tested, other testable statements can be deduced. Thus, if the basic statements in their turn are to be intersubjectively testable, there can be no ultimate statements in science, there can be no statements in science which cannot be tested, and therefore none which cannot in principle be refuted, by falsifying some of the conclusions which can be deduced from them. We thus arrive at the following view. Systems of theories are tested by deducing from them statements of a lesser level of universality. These statements in their turn, since they are to be intersubjectively testable, must be testable in like manner and so ad infinitum. It might be thought that this view leads to an innate regress, and that it is therefore untenable. In section, when criticizing induction, I raised the objection that it may lead to an innate regress, and it might well appear to the reader now that the very same objection can be urged against that procedure of deductive testing which I myself advocate. However, this is not so. The deductive method of testing cannot establish or justify the statements which are being tested, nor is it intended to do so. Thus there is no danger of an innate regress. But it must be admitted that the situation to which I have drawn attention, testability ad infinitum, and the absence of ultimate statements which are not in need of tests, does create a problem. For, clearly, tests cannot in fact be carried on ad infinitum. Sooner or later we have to stop. Without discussing this problem here in detail, I only wish to point out that the fact that the tests cannot go on forever does not clash with my demand that every scientific statement must be testable. For I do not demand that every scientific statement must have in fact been tested before it is accepted. I only demand that every such statement must be capable of being tested, or in other words, I refuse to accept the view that there are statements in science which we have, resignedly, to accept as true merely because it does not seem possible, for logical reasons, to test them. On the problem of a theory of scientific method. In accordance with my proposal made above, epistemology, or the logic of scientific discovery, should be identified with the theory of scientific method. The theory of method, in so far as it goes beyond the purely logical analysis of the relations between scientific statements, is concerned with the choice of methods with decisions about the way in which scientific statements are to be dealt with. These decisions will of course depend in their turn upon the aim which we choose from among a number of possible aims. The decision here proposed for laying down suitable rules for what I call the empirical method is closely connected with my criterion of demarcation. I propose to adopt such rules as will ensure the testability of scientific statements, which is to say, their falsifiability. 7. Why methodological decisions are indispensable. What are rules of scientific method, and why do we need them? Can there be a theory of such rules, a methodology? The way in which one answers these questions will largely depend upon one's attitude to science. Those who, like the positivists, see empirical science as a system of statements which satisfy certain logical criteria, such as meaningfulness or variability, will give one answer. A very different answer will be given by those who tend to see, as I do, the distinguishing characteristic of empirical statements in their susceptibility to revision in the fact that they can be criticized, and superseded by better ones, and who regard it as their task to analyze the characteristic ability of science to advance, and the characteristic manner in which a choice is made, in crucial cases, between connecting systems of theories. I am quite ready to admit that there is a need for a purely logical analysis of theories, for an analysis which takes no account of how they change and develop. But this kind of analysis does not elucidate those aspects of the empirical sciences which I, for one, so highly prize. A system such as classical mechanics may be scientific to any degree you like, but those who uphold it dogmatically believing, perhaps, that it is their business to defend such a successful system against criticism as long as it is not conclusively disproved are adopting the very reverse of that critical attitude which in my view is the proper one for the scientist. In point of fact, no conclusive disproof of a theory can ever be produced, for it is always possible to say that the experimental results are not reliable, or that the discrepancies which are asserted to exist between the experimental results and the theory are only apparent and that they will disappear with the advance of our understanding. In the struggle against Einstein, both these arguments were often used in support of Newtonian mechanics, and similar arguments abound in the field of the social sciences. If you insist on strict proof, or strict disproof, in the empirical sciences, you will never benefit from experience, and never learn from it how wrong you are. If therefore we characterize empirical science merely by the formal or logical structure of its statements, we shall not be able to exclude from it that prevalent form of metaphysics which results from elevating an obsolete scientific theory into an incontrovertible truth. Such are my reasons for proposing that empirical science should be characterized by its methods, by our manner of dealing with scientific systems, by what we do with them and what we do to them. Thus I shall try to establish the rules, or if you will the norms, by which the scientist is guided when he is engaged in research or in discovery, in the sense here understood. 8. The naturalistic approach to the theory of method. The hint I gave in the previous section as to the deep-seated difference between my position and that of the positivists is in need of some amplification. The positivist dislikes the idea that there should be meaningful problems outside the field of positive empirical science, problems to be dealt with by a genuine philosophical theory. He dislikes the idea that there should be a genuine theory of knowledge, an epistemology, or a methodology. He wishes to see in the alleged philosophical problems mere pseudo-problems or puzzles. Now this wish of his, which, by the way, he does not express as a wish or a proposal but rather as a statement of fact, can always be graded. For nothing is easier than to unmask a problem as meaningless or pseudo. All you have to do is to X upon a conveniently narrow meaning for meaning, and you will soon be bound to say of any inconvenient question that you are unable to detect any meaning in it. Moreover, if you admit as meaningful none except problems in natural science, any debate about the concept of meaning will also turn out to be meaningless. The dogma of meaning, once enthroned, is elevated forever above the batle. It can no longer be attacked. It has become, in Wittgenstein's own words, unassailable and definitive. The controversial question whether philosophy exists, or has any right to exist, is almost as old as philosophy itself. Time and again an entirely new philosophical movement arises which nally unmasks the old philosophical problems as pseudo-problems, and which confronts the wicked nonsense of philosophy with the good sense of meaningful, positive, empirical, science. And time and again do the despised defenders of traditional philosophy try to explain to the leaders of the latest positivistic assault that the main problem of philosophy is the critical analysis of the appeal to the authority of experience, precisely that experience which every latest discoverer of positivism is, as ever, artlessly taking for granted. To such objections, however, the positivist only replies with a shrug. They mean nothing to him, since they do not belong to empirical science, which alone is meaningful. Experience for him is a program, not a problem, unless it is studied by empirical psychology. I do not think positivists are likely to respond any differently to my own attempts to analyze experience, which I interpret as the method of empirical science. For only two kinds of statement exist for them, logical tautologies and empirical statements. If methodology is not logic, then, they will conclude, it must be a branch of some empirical science, the science, say, of the behavior of scientists at work. This view, according to which methodology is an empirical science in its turn a study of the actual behavior of scientists, or of the actual procedure of science, may be described as naturalistic. A naturalistic methodology, sometimes called an inductive theory of science, has its value, no doubt. A student of the logic of science may well take an interest in it, and learn from it. But what I call methodology should not be taken for an empirical science. I do not believe that it is possible to decide, by using the methods of an empirical science, such controversial questions as whether science actually uses a principle of induction or not. And my doubts increase when I remember that what is to be called a science and who is to be called a scientist must always remain a matter of convention or decision. I believe that questions of this kind should be treated in a different way. For example, we may consider and compare two different systems of methodological rules, one with, and one without, a principle of induction. And we may then examine whether such a principle, once introduced, can be applied without giving rise to inconsistencies, whether it helps us, and whether we really need it. It is this type of inquiry which leads me to dispense with the principle of induction, not because such a principle is as a matter of fact never used in science, but because I think that it is not needed, that it does not help us, and that it even gives rise to inconsistencies. Thus I reject the naturalistic view. It is uncritical. Its upholders fail to notice that whenever they believe themselves to have discovered a fact, they have only proposed a convention. Hence the convention is liable to turn into a dogma. This criticism of the naturalistic view applies not only to its criterion of meaning, but also to its idea of science, and consequently to its idea of empirical method. 9 Methodological rules as conventions. Methodological rules are here regarded as conventions. They might be described as the rules of the game of empirical science. They differ from the rules of pure logic rather as do the rules of chess, which few would regard as part of pure logic, seeing that the rules of pure logic govern transformations of linguistic formulae. The result of an inquiry into the rules of chess could perhaps be entitled the logic of chess, but hardly logic pure and simple. Similarly, the result of an inquiry into the rules of the game of science, that is, of scientific discovery, may be entitled the logic of scientific discovery. 2 simple examples of methodological rules may be given. They will assist to show that it would be hardly suitable to place an inquiry into method on the same level as a purely logical inquiry. 1. The game of science is, in principle, without end. He who decides one day that scientific statements do not call for any further test, and that they can be regarded as nulli verid, retires from the game. 2. Once a hypothesis has been proposed and tested, and has proved its mettle, it may not be allowed to drop out without good reason. A good reason may be, for instance, replacement of the hypothesis by another which is better testable, or the falsification of one of the consequences of the hypothesis. The concept better testable will later be analyzed more fully. These 2 examples show what methodological rules look like. Clearly they are very different from the rules usually called logical. Although logic may perhaps set up criteria for deciding whether a statement is testable, it certainly is not concerned with the question whether anyone exerts himself to test it. In section I tried to deal empirical science with the help of the criterion of falsifiability, but as I was obliged to admit the justice of certain objections, I promised a methodological supplement to my definition. Just as chess might be deemed by the rules proper to it, so empirical science may be deemed by means of its methodological rules. In establishing these rules we may proceed systematically. First, a supreme rule is laid down which serves as a kind of norm for deciding upon the remaining rules, and which is thus a rule of a higher type. It is the rule which says that the other rules of scientific procedure must be designed in such a way that they do not protect any statement in science against falsification. Methodological rules are thus closely connected both with other methodological rules and with our criterion of demarcation. But the connection is not a strictly deductive or logical one. It results, rather, from the fact that the rules are constructed with the aim of ensuring the applicability of our criterion of demarcation, thus their formulation and acceptance proceeds according to a practical rule of a higher type. An example of this has been given above. Cf. rule theories which we decide not to submit to any further test would no longer be falsifiable. It is this systematic connection between the rules which makes it appropriate to speak of a theory of method. Admittedly, the pronouncements of this theory are, as our examples show, for the most part conventions of a fairly obvious kind. Profound truths are not to be expected of methodology. Nevertheless, it may help us in many cases to clarify the logical situation, and even to solve some far-reaching problems which have hitherto proved intractable. One of these, for example, is the problem of deciding whether a probability statement should be accepted or rejected. Cf. section. It has often been doubted whether the various problems of the theory of knowledge stand in any systematic relation to one another, and also whether they can be treated systematically. I hope to show in this book that these doubts are unjustified. The point is of some importance. My only reason for proposing my criterion of demarcation is that it is fruitful, that a great many points can be clarified and explained with its help. Definitions are dogmas, only the conclusions drawn from them can afford us any new insight, says Menger. This is certainly true of the definition of the concept science. It is only from the consequences of my definition of empirical science, and from the methodological decisions which depend upon this definition, that the scientist will be able to see how far it conforms to his intuitive idea of the goal of his endeavors. The philosopher too will accept my definition as useful only if he can accept its consequences. We must satisfy him that these consequences enable us to detect inconsistencies and inadequacies in older theories of knowledge, and to trace these back to the fundamental assumptions and conventions from which they spring. But we must also satisfy him that our own proposals are not threatened by the same kind of difficulties. This method of detecting and resolving contradictions is applied also within science itself, but it is of particular importance in the theory of knowledge. It is by this method, if by any, that methodological conventions might be justified, and might prove their value. Whether philosophers will regard these methodological investigations as belonging to philosophy is, I fear, very doubtful, but this does not really matter much. Yet it may be worth mentioning in this connection that not a few doctrines which are metaphysical, and thus certainly philosophical, could be interpreted as typical hypostatizations of methodological rules. An example of this, in the shape of what is called the principle of causality, will be discussed in the next section. Another example which we have already encountered is the problem of objectivity. For the requirement of scientific objectivity can also be interpreted as a methodological rule, the rule that only such statements may be introduced in science as are intersubjectively testable, see sections 0 and elsewhere. It might indeed be said that the majority of the problems of theoretical philosophy, and the most interesting ones, can be reinterpreted in this way as problems of method.